gents. We are in week 5. Okay, we're going to finish through the radians, okay, and that means next lesson we're going to be able to start working with proper calculus, so we're going to start working with functions. Yeah, that's the beginning. I think I'm just going to do, yeah, well, we'll see about that. Anyway, so let's have a look. We've got a circle, okay. That stuff, by the way, I'm not using lights here, so tell me if it's better without the lights, okay? That was one, I think, request from Olivia. Hopefully you can see it, okay? Otherwise I have to repeat everything with light, but hopefully this is good. Okay, so we've got a circle, that's the center. We've got radiuses, and we've got the angle, theta, and the, not the circumference, but the length of this arc is L. And what we're going to do today, we're going to find out the area of this slice of cake, okay? We're looking at slices of cake. In mathematics, the words they use is area sector of a circle. But let's be honest, these are slices of cake. What kind of cake? Chocolate cake. Or cheesecake. Okay? So we're trying to create a formula to find the area, the area of that slice of cake. Okay? So the best way to start, the place to start is to say, okay, let's have a look at that area. If I divide it by the area of the whole circle, okay, what's the area of the whole circle? Pi r squared, right? So if I divide the area of the slice of cake divided by the area of the whole cake, okay, what are we going to get? We're going to get, it's a ratio, right? It's a ratio between the area of the slice to the area of the whole circle, okay? The ratio will be the same ratio as the ratio between the angle of this cake divided by what? Well, normally you'll say by 360, by the angle of the whole full cake, okay? But remember, we're not working with 360, we're working with radians. So how many radians in the full circle? 2 pi. Okay? So I'll just explain that again. All right? By the way, we're in page 54, exercise 2.3. Okay? The area of the slice of cake divided by the full cake, okay, pi r squared. Okay? Now, that ratio between this cake and the slice and the whole cake is the same as the area between this angle and the full maximum angle, okay, which is 2 pi. Okay? And then by moving that around, I'll move that to the other side. So A is going to be equal to pi r squared divided by 2 pi. A equal half r squared. Okay? And that's our equation that we just developed together. Thank you very much. Okay? The area of a slice of cake is half times the radius squared. Cool, isn't it? Okay, just pause you here. It's so cool, but obviously I made a mistake. That's why it's a good thing I just checked. Okay? So obviously I forgot the theta. Okay? How did you not tell me? See, if you were here, you would shout me straight away. Okay? So by pushing the pi r squared, I shouldn't really leave theta, okay? There's also a theta here. Hoping you can see it, okay? I'll maybe write it again, just a bit bigger. So it's going to be pi r squared theta divided by 2 pi, and that's half r squared theta, okay? Do not forget the theta. Okay. Right. So that's our first equation that we're going to use to solve questions about area of slices of cake. But I'm just going to add another equation that we mustn't forget. That's the equation of the definition of the angle theta in radians. Okay? So the definition, if you remember, of theta, okay, is, what was it? It was L over R. Am I right? And let's just pause that for a second. Okay, yes. I just wanted to make sure that I've got the right equation. So the angle theta is the arc, it's the ratio between the arc and the radius, okay, in radians. Now, let's do the first very easy question. So they tell us, look, you've got an angle theta of 0,8 radians. The radius we don't know, the arc we don't know, but we know the area is 28,9. Find out the radius. Okay, that's not a problem. And we just substitute in this equation, okay? So 28,9 equal half times r squared times 0,8. Rearranging, r equals square root, okay? First I need to time 2 times 28,9 divided by 0,8, and you get an answer, okay? I picked up the example from the book, so it's 8.5, looks like. Okay? Right, that's really easy stuff, and there's a bunch of questions that are on this level and maybe a little bit higher, but I want to just aim a little bit higher than that. So let's move on to the next level. I'll just pause you and put it on the board. Okay, right, so next example. Right. So now, we've got another circle, radiuses, okay? Always just, it's the center of the circle, okay? I know that's theta. And what I want to do, what they're asking me is to prove that the area of the smiley face, okay, area of the smiley face, or the watermelon slice, okay, is half r squared in brackets, time brackets, theta minus theta. Okay. Now, I can see, if I open it up, if I start opening these things, foil them, I can see my half r squared theta. Half r squared theta. Okay? So it can put me in the right direction. How would I find the area of this watermelon slice? Okay? The area of the watermelon slice, okay, is really the area of the cake slice, okay, this whole cake slice, AOB, okay, minus the area of the triangle, right? The triangle AOB. Okay, oops. Minus the area of triangle AOB. Hope you understand what I'm drawing here. Okay? So the area of the watermelon slice is the area of the whole cake slice minus a triangle. Okay? And the area of this cake slice, I know, is simply half r squared theta. So I just need to find out the area of the triangle. Now, this is the thing, like Gordon Ramsay says. This is the thing. MasterChef. I'm not sure if you learned that rule. There is a rule in trig called the area rule. There's actually 3 rules: the sine rule, the cosine rule, and the trig rule, and the area rule. And I'm pretty sure you're learning at grade 11, but I don't know if you got into trig yet. So you might have not done that yet. And if you haven't, you'll just have to take my word for it. I'm not going to prove it here. This is not the time. You'll do it in normal maths. If you've got a triangle, A, B, C, okay? And little c is the length of this side, opposite C. Little a is the side opposite A, and B is the side opposite B. There's a way of calculating the area of this triangle without finding the perpendicular line. Okay? There's another way. And what you've got to do is you've got to take 2 sides. Let's say A and B. And you see these 2 sides, A and B. Okay? And what you've got to do is you time half by A by B. So half times A times B. And you time it by sine the angle between them. So half times A times B times sine the angle between them. You can prove it with some elementary trick, but I'm not going to do it here. Hopefully you'll do it in maths. Okay? So this allows me to calculate the area of this triangle, AOB. Right? So the area is going to be half times A. Okay, which sides are we going to use? Well, we don't know what the length of this side, so I'm not going to use it. I'm going to use those 2 sides. So it's going to be half times R, so half R squared, times sine, the angle between them, which is theta, isn't it? Okay? And then all I've got to do is find the common factor, which is very easy, half R squared. Can you still see that? You can. Brackets, theta minus sine theta. Okay? And that was what we asked to prove. Okay? So, yeah, I'm going to pause you here, and I'm going to put one more last example, and that will be this lesson. Okay, guys, last example, and now I switched on the light, just this is for you to see what is better, because I'm not sure. Without the light, might be a bit too dark. With the light, I know at the top of the board, it's a little bit difficult to read. So you guys tell me, okay? This is the last example, and I think that's as hard, as difficult as these quick exercises go to, I think. I didn't go through all of them. And by the way, I must just say it now, that there are mistakes in the memos sometimes, as Rachel already discovered last time. So if it doesn't work together, drop me a line and I'll check it for you, okay? Right, so we've got half a circle, radiuses are, we've got an angle of this segment. This is, by the way, we can call it a segment as well, okay? That slice of cake, okay? And we've got that watermelon, okay? Oh, sorry, this is a sector, and this way they call it a segment. We call it a watermelon slice. And they also tell us that the area of triangle AOC, okay, I need to make one more line here. So the area of this triangle AOC is 3 times the area of the watermelon, the shaded area, okay? And what do they want to show? What do we want to prove? They tell us we must prove that 3 theta minus 4 sine theta equals 0. Some kind of trigonometric equation. We need to prove that. Okay? Okay. Let's start by finding the area of the triangle, of the watermelon. So area of the watermelon. Okay? I just erased it. Okay? We just developed in the question before that a formula that you're not required to remember. I don't think so. No, you don't need to remember that. You need to remember those, but you don't need to remember the other one. Okay, so what was the formula? I'll just rewrite it again. So the area of a segment, like the leftover from the triangle, is half r squared. So it starts like a half r squared, but instead of theta, we've got theta minus sine theta. And so it starts the same, because what is half r squared theta is the area of this whole slice of cake. But we've got minus theta, because we're getting rid of that triangle. Okay, so that's the area of the watermelon. Now let's look at the area of triangle AOC. Again, we've got this, what do you call it? The area rule, okay, which tells you, unfortunately I erased it, it's half times A times B, half timing 2 sides of the triangle, times sine the angle between them. So you multiply 2 sides, you multiply it by the sine of the angle between those 2 sides. So let's have a look at the 2 sides. The 2 sides are r and r, so it's going to be half r squared times sine the angle between them. But what is the angle between them? Okay, well, if this is theta, this normally you would say 180 minus theta, but remember, and maybe I should have said that, that equation, very important, very, very important, that equation, A equal half times r squared theta, only works for radian, okay? Really, I should have said that in the beginning. That's only for radian. It doesn't work with degrees, okay? Because when we developed it, we used the definition of the radian. So I can't say this is 180 minus theta. Instead, I will say it's pi minus theta. Because remember, 2 pi is 360. Important to remember these things. 2 pi is 360, pi is 180, and therefore half a pi is 90. And you even probably should know that quarter pi divided by 4 is 45. They're important ratios to remember, angles to remember. Okay, so it's half r squared times sine the angle between them, which is pi minus theta. Okay, now comes the second part of trig. Again, I don't know if you've done trig this year, okay? But one of the things you know in trig, you learn in trig, is that sine pi minus, or I'll write it down here. Sine 180 minus theta, okay, is equal to sine theta. Okay, if you do sine 180 minus theta, it's sine theta. Okay, it's the same. Okay, some identity that you're going to learn this year if you haven't learned it yet. But you will, definitely. Okay, so this is in degrees. Now, when we come to radian, it's not 180, it's pi. So I can rewrite that as half r squared sine theta. Okay, we're almost there. I don't want to run out of memory, so we're going to speed up. The area of this triangle, half r squared sine theta, is 3 times the area of the segment. So 3 times half r squared theta minus sine theta. Okay, I can cancel the r squared in the half, times it by 2 over r squared. Okay? And I'm ending up with sine theta equal 3 theta minus 3 sine theta. Move the 3 sine, I just open it up. Move the 3 sine theta to the other side. And what do I get? No, sorry. No. I'll move the sine theta over there, so I'll get 0 equal 3 theta. I move the sine theta on this side, so it will be 4 sine theta. And that's what I wanted to prove. That's what I want to prove. So I'm going to pause here. And guys, I think this is it. I'm not going to give you another lesson because this is quite a long lesson. And I think I'd like you to really revise all these questions. There are quite a lot of questions and some of them could be quite difficult. And if you come up with some difficult one, just let me know and I will go over it and I can do another little video for that. Instead of me jumping on now to function, which is like a completely different unit, let's take our time. Please guys, you need to spend another hour on top of what the 60 minutes, 1 hour to solve problems in page 56 to all the way to 58. 54 to 58. Okay? 1 more hour guys. Okay? Have a lovely day. See you next week.